Good morning, everyone. I just wanted everyone to know that the sound should be working and everyone should be joining. We're just going to wait just a minute until we get a few more of the attendees that said that they were joining. Thanks for coming along today. We've got quite a packed agenda for you with quite a number of speakers, so hopefully this will be very interesting. We are also recording the webinar and we'll be able to send that out afterwards. All right, I think we should make a start. Well, welcome to everybody. Thank you for coming along to our Solutions for Biogas, Biomethane, RNG webinar today. We are going to start off just by testing the Q&A button because we're going to be running a Q&A session at the end. So just wanted to draw everyone's attention to a Q&A button at the bottom of the screen. And perhaps if you want to pop in there where you're signing in from today and even what the weather's like. I'm in the UK Midlands and it is a rather rainy day. Thanks for those questions. Right, we've got Mariam who says that it's cloudy in Hampshire. Nelson is in Kenya, Africa, and it's a cloudy day. Fabulous. Rinret is in Nigeria and it's a cloudy day. So as you can see, we've got quite the cohort today. Thank you for those answers. So I think if we kick off, Benjamin is going to take the lead for us today, and he's going to just welcome you and go through the little biography of our main speaker, Avinash. Let me click onto the right slide for us. There we go. Benjamin, do you want to take us through the agenda for today?
Yes, please. You have a next slide, Corinne, or we do that?
Yeah, just wanted to run through the agenda for today.
Okay, so for today, thank you for joining first. So here is the agenda. We're gonna see the biogas market overview and the big trends, and then we're gonna present you the different solutions that we have at Ingersoll Rand for this big market. So it's about odorization, it's about industrial IoT, pumps, of course, mixers and compressors, and then we're gonna have a session for the Q&A. So do not hesitate. Again, if you have questions during the presentation, you can write in the Q&A button here, or we can, and we will answer the question at the end of the webinar.
Fabulous. Will you introduce our guest, Benjamin?
So today we have our special guest, Avinash Ravi, Senior Strategist Analyst at Ingersoll Rand. He has 30 years of experience in the strategic consulting, market research, supply chain optimization and strategies, and experience with providing go-to-market strategy across industrial automation and sustainability markets. And the background is mechanical engineer and certified professional in supply management. So welcome, Avinash, today.
Yeah, Thank you, Benjamin. Sure. Good morning to everyone, and welcome to the Biomethane webinar. In this section, we will be covering market trends, feedstock details, biomethane usage, policies, regulatory landscape across the European biomethane market, and also touch upon different equipment offered by Ingersoll Rand for the biomethane value chain. Firstly, an introduction to what Ingersoll Rand does as a company. We are the market leader in mission-critical flow creation technology. What I mean by mission-critical flow technology is the essential task of moving fluids with the help of our products, such as compressors, blowers, vacuums, pumps, in critical applications and industrial settings where safety, optimized efficiency, and uninterrupted uptime are paramount to our customers. So last fiscal year, our revenue soared to almost $7 billion with a 26% EBITDA margin and over $1 billion in free cash flow that enabled us to drive performance. We have a workforce of 18,000 employees across 65 plus manufacturing sites and 150 plus customer service centers worldwide. With an installed base of 5 million assets that are connected digitally, as we move towards digitalization, we hold the top spot or a second close in the markets that we operate in. So that summarizes an overview about what Ingersoll Rand does as a company. So moving on to the next slide. So what you see here is a simplified version of the biomethane production process. There are 3 key stages in the process. First is the processing of different feedstocks for the anaerobic digestion, then the production of biogas itself, and finally, the upgrading or compression and upgrading of the biogas into biomethane. Feedstocks could include energy crops, agricultural residues, or organic waste. That could be municipal, household, or industrial organic waste. Then we have sewage sludge from the wastewater treatment plants. Finally, landfill gas, which is nothing but a resultant of natural decomposition of organic waste collected in landfill sites. Through anaerobic digestion of these feedstocks, biogas is produced with methane content of 50 to 70%. Then upgrading of this biogas results in production of biomethane. I will get into the details of the production process in the subsequent slides. However, it is noteworthy that there are other new emerging technologies such as thermal and hydrogasification, but these are yet to be commercialized but will aid in achieving the 35 BCM, that is billion cubic meter target set by EU by the year 2030. Moving on to the next slide. So this slide talks about the European feedstock mix and biomethane usage by European countries. European countries use different mixes of feedstocks and in different percentages. Production and success of biomethane projects depend on 2 factors or aspects. One is availability of feedstock, and the other is whether the policy and regulatory landscape is favorable to the production of biomethane or not. We will talk about policies and regulations in the next slide. In terms of feedstock, Germany and the UK rely heavily on dedicated energy crops for the biogas production. On the other hand, France and Netherlands, Denmark, along with Belgium, predominantly utilize agricultural residues. And this method accounted for 45 to 50% of the total mix in 2023. And it showed considerable promise in reducing methane emissions from the agricultural activities. Now, for landfill gas, despite experiencing a significant increase in adoption since its inception in 2017, the utilization of landfill gas remains minimal with the European countries. Similarly, consumption of biomethane varies across different countries. For instance, Sweden, Finland, Italy focuses on transportation, while Germany, UK, France, Switzerland, with their grid infrastructure, focus on other end markets, including heating, power generation, alongside transportation. Moving to the next slide. This slide provides an overview of laws, regulations, policies that impact biomethane production across the globe. We'll focus on Europe for this webinar. Now, several legislative measures have profoundly influenced European Union's efforts in decarbonizing and reducing green gas emissions. Among these, the pivotal directives include the Renewable Energy Directive of 2008-2009, also known as RED1, which aimed for 20% renewable energy by 2020. And there was an amendment. Then in 2019, RED2 came, which set a higher goal of 32% by 2030. Now, there were a lot of changes in the past few years. For instance, in July 2021, there was a proposal to increase this target to 40% as part of the Fit for 55 plan. Now, following Russia's invasion of Ukraine, there was a push to raise the target up to 45% by 2030. The deal was reached in March 2023 to at least set it to 42.5%. And the new directive known as RED3 was published on October 31, 2023. Now, there are other regulations that focus on the feedstock aspect and digestate, which is the byproduct of production value chain as such. And collectively, these regulations aim to foster an energy-efficient, circular, and renewable energy ecosystem, thereby driving the demand for biomethane production within Europe. Next slide, please. This slide talks about the demand drivers for biomethane production. EU natural gas production continued its decreasing trend, falling by almost 19% in 2023 year on year. And the EU's natural gas import dependency rate was still at 90%, highlighting the need to develop biomethane production capabilities to reduce this dependency. And additionally, political and economic instability, largely due to Ukraine war and disruption of natural gas supply from Russia, has increased the investment towards other low carbon fuel options, including biomethane across Europe. The chart that you see on the bottom left side of the slide showcases the need to decarbonize heavy-duty trucks, which account for approximately 25% of global road emissions, with 97% of the trucks sold in EU powered by diesel. Biomethane is expected to play a pivotal role in decarbonizing heavy truck industry and also other transportations like marine industry or road transportations. As you can see, in 2023, the installation of bio-LNG plants nearly doubled to almost to 55 from a value of 27 in compared to previous year. A similar trajectory of rapid expansion is anticipated for the year 2024 too. And as discussed, policies, financial incentives, investment support, feed-in tariffs play a major role and will continue to drive the biomethane market. Another key driver is the biogenic CO2. Biogenic CO2 is produced as a byproduct of biomethane production. When coupled with green hydrogen, it holds the potential to fuel production of renewable synthetic fuels, including synthetic kerosene, synthetic diesel, and synthetic methane as well. Additionally, captured biogenic CO2 and its usage in different applications like F&B and other industry play a major role in reducing the overall CO2 emission. The last one is, of course, the return on investment. While anaerobic digestion production pathway requires initial investment for setup and operation, the economic advantages stemming from the production of biomethane will surpass the associated cost or expenses. The return on investment, both in terms of financial profitability and environmental sustainability, are considerable for production of biomethane within Europe. That sums up the demand drivers for biomethane within Europe. Moving on to the next slide. Thank you. So this is the supply slide. As discussed earlier, biomethane offers a significant potential to diversify gas supply, enhance EU energy independence, and also mitigate the impact of natural gas price fluctuations. The EU aims to reach an annual biomethane production of 35 billion cubic meters in the EU by 2030. As of 2023, Europe's biomethane production capacity stands at approximately 4.2 billion cubic meter per year, with 3.4 actually coming from EU itself. Biomethane production varies greatly among EU countries, mainly due to their different national strategies, policies, financial support, the feed-in tariffs, and also the plant size itself. For instance, France has experienced a remarkable growth in the last year or so, with number of biomethane plants increasing from 131 in 2020 to 500 or 514 in 2022. Now surpassing Germany's count of 254 facilities. Despite the difference in plant numbers, Germany still leads overall biomethane production, contributing around 30% of Europe's total. That's mainly because Germany's average plant size is close to 582 cubic meter per hour, whereas France tends to be on the smaller installation size, averaging about 200 or maybe less than that cubic meter per hour. Across Europe, the average plant size is approximately 460 cubic meter per hour, whereas Denmark, the UK, Italy have largest average capacities ranging from somewhere between 900 to 1500, I would say, whereas France, Finland, Switzerland are on the other end. They're on the smallest end. They are somewhere between 150 to 185 cubic meter per hour. According to the 2013 National Energy and Climate Plans, the EU is expected to produce 20.2 BCM of biomethane by 2030, which is actually a shortfall of 10.3 from the target of 35 BCM. This indicates the need for urgent action across the board, and our estimate on the right-hand side of the slide suggests for the EU to reach, or even Europe to reach, the target of 35 BCM, it needs to grow by a CAGR of almost 27% in the coming years. That sums up the supply slide. We'll move to the next slide. Thank you. This is the production process slide. As mentioned in the simplified version, the key stages in biomethane production are feedstock processing, biogas production, biogas compression and upgrading. On the anaerobic digestion side, we see within feedstock processing, based on whether the feedstock is wet, semi-liquid, different sub-processes include cutting, shredding, separation, these feedstock with the help of solid matter feeders or shredders, separators, and submersible mixers. Additionally, different pumps are used. Progressive cavity, rotary low, peristaltics pumps are used for feeding the substrate into the anaerobic digester. Some metering pumps are also used for chemical dosing, and there are few submersible centrifugal pumps used for general flow duties in sumps and chambers. Ingersoll Rand, as you will see in our product slides, we offer CPEX brand that supplies progressive cavity pumps, Albin pumps that supplies peristaltic pumps, LMI that supplies metering pumps for this segment. After the substrate is fed into the anaerobic digester, there are typically 4 stages of anaerobic digestion that happens: hydrolysis, acidogenesis, methanogenesis, and anaerobic digestion can be of 2 types based on what temperature it is operating at. For instance, previous slide, yeah. Mesophilic digestion is on a lower side, that is 35 to 45 Celsius, whereas thermophilic is on a higher temperature, which is 55 to 60 Celsius. Additionally, on the landfill gas side, where collection and decomposition of organic material into landfill results in production of landfill gas, are multi-stage centrifugal blowers from Hoffman and Lamson are used here. Once the biogas, everything is sent into anaerobic digester, especially from the feedstock processing stage, and the digestion happens, we know that there is another process which could happen. It could be a dehumidification or H2S removal, and biogas is sent for compression. Rotary screw compressor is used, that the pressure ranges between 12 to 17 bar, and based on the water content, a chiller or a condensate dryer system can be used. And there are different upgrading technologies like membrane technology, PSA, pressure swing adsorption, chemical absorption, water scrubbing, cryogenic processes. And an additional nitrogen rejection unit is required for landfill gases. So once that purification is done, then the biomethane, or as it's known as RNG in the North American market, is produced with a methane content of 95 to 97% methane content biomethane is produced. Once the biomethane is produced, based on the end application, whether it goes into an RNG or a biomethane tube truck, if the pipeline is far away, a reciprocating compressor will be used to further compress it to 230 to 250 bars. But odorizer systems are used to odorize the biomethane. If it's going into the injection grids, then there are screw pumps or even, screw compressors and reciprocating compressors used. That's where our products are used. And also we have Aircom IoT telematics solution that would give us a long-range process monitoring in these hazardous environments. So that sums up the production process and different equipment that of Ingersoll Rand that I used in the production value chain. So with that, I'll pass it to Louis for the product slides.
So thanks, Avinash. So my name is Louis Vola, and I am in charge of the development of YZ business for odorization in EMEA. So we can go on our slide. So as mentioned, the world transition toward cleaner energy sources, and biomethane is gaining significant momentum. So you can see on this diagram that the number of sites in France increase a lot, and forecast plan is quite interesting also for the future. And as natural gas, the biomethane produced is odorless gas. So odorizing biomethane is crucial for safety reasons and for its distribution. So odorization adds a smell, so leaks can be detected quickly. And regarding country policies, as mentioned, every country has its own recipe. The type and amount of odorant can be different for each one. So next slide, please. Up. Sorry. Up. Okay. So imagine a mini factory that injects biomethane into the gas network. So we need to consider that biomethane has three main components. The first one is a gas analyzer. Similar to gas inspectors, they are like gas quality checkers, making sure everything is up to spec before it goes directly in the gas grid, in the network. After you have the skid gas or gas meter. This measures the amount of gas and helps determine cost and tarification of the gas. And after, the third part is the odorizer. This adds the smelly hint into the biomethane, making leaks detectable. Next slide, please. So here you can have an overview of injection station. So you can see these three parts: odorization area, analytical station, where inside we have also the PLC automation system to control the installation, and the skid gas. What is important to consider is the fact that in odorization, we work in hazardous area, so it's a classified area, and so we need to have ATEX or CSA certified equipment. Next slide, please. So regarding challenges, the major one is a super low gas flow. This is very characteristic from biomethane. Biomethane flow rates can be very low. When you say very low, the ranging go from 15 to 800 cubic meter per hour. So making odorization a delicate process. So specialized pumps are required to inject precise and tiny amounts of odorants. This is equivalent to inject a volume of odorant as small as 0.2 milliliter per hour, like a drop, in fact. So maintaining a target odorant concentration is a real challenge. The odorizer system must be precisely controlled, the odorant injection and maintain a consistent concentration within a specified range. So under odorization can lead to undetected leaks and generate production shutdown, which will be critical, while over odorization can generate unpleasant odors or generate high additive cost. So it's very challenging to have an accurate injection. Next slide, please. So in addition, we need to consider, again, first, the safety. After regarding odorizer system itself, it cannot leak any odor. On picture, as example, you can see a YZ odorizer installed outside at the middle of residential areas, no complaints. Nobody knows odorizer is here. We also need to consider space, as this system often need to fit in a tight spaces. Keeping unit compact is also important, and of course, producers want efficient odorizer at a good price. So finding the right price is crucial, but maintaining high performance levels. Next slide, please. So YZ Systems odorizer are designed specifically for biomethane's low flow rate. Our models include LVO, low volume odorizer, a simply and easy to use skid for low volume odorization. The ZO, zero emission odorizer, a fully automatic electrical system dedicated also for a high level of odorization. And both systems can work together, or we can have a redundancy of equipment when needed, depending on the policy of each country. Next slide, please. Last point is regarding the references. The YZ odorizer have been recognized by leading gas company over here, more than 40 years of experience in this area in US and other countries. And our odorizer have been selected after European tender managed by GRDF, a leader in gas distribution in France, to equip on 10 coming years their biomethane injection station. So just to finalize, considering that biomethane is a clean energy source with a great potential in Europe, the odorization is a crucial for its safe and efficient distribution, and YZ provide high-performance odorizing system for the biomethane industry. So we are at your disposal. If you have some question on this point, feel free to contact us for any question. Thanks for your time.
Fantastic. Thanks, Louis. So I'm Steve Hoffman, the Managing Director for AirCom Industrial IoT. We're going to talk a little bit about some of the telemetry solutions that you can apply to your RNG process. Louis is my colleague and also our business development manager for EMEA on the AirCom product line as well, which is part of YZ. So the AirCom product is a sensor agnostic hazardous area telemetry solution that can monitor basically any part of your RNG process, ranging from your odorizer to different pressures, gas quality, all the way up into the production side as well. So you go to the next slide, please. Key benefits of AirCom, which leverages LoRaWAN as the communication protocol. So you can bring in to a single AirCom unit up to 5 analogs, 4 digital, and 2 serial inputs from any instrument. You can send that data up to 10 miles, depending on topography, and have up to 10-year battery life in that application to power the sensor and take the readings. The data is encrypted end-to-end, so it's AES-128 encrypted. And it allows you to save money compared to legacy solutions. So typically to install our system is less than it will cost you just to bring out, say, a hydrovac machine or something like that to trench and run conduit. And it is ATEX Zone 0 and Class 1 Div 1 approved, so it can sit right there in the hazardous areas, taking readings from sensors and sending those back. So how does LoRaWAN work at a high level? So you've got the end nodes, which would be those hazardous area devices you're seeing in the previous picture that are connected up to the sensors in your process, sending that data up to 10 miles to a gateway. That gateway is forwarding that data on to a cloud server. And ultimately from that cloud server, then you can bring that data out to other applications if you want to through MQTT or other APIs that we can integrate in there so that you can view that data wherever you want to see all your data together. Next slide, please. So just to highlight our AirCom ADHD end node, and you can see there the difference with the HD is we add 3 additional analog inputs on it. So with the AirCom end nodes, you can have up to 5 analog inputs. So we can loop power those instruments, take the readings and send them back. 2 of those are highly configurable for either active, passive, HART, RTD, thermocouple, voltage, or resistance. The other 3 on the HD are just going to be passive only. 4 volt-free digital inputs. Those are configurable. The first 2 can be configured as a pulse count input for, say, a flow meter that you may have monitoring gas. And then the last 2 can be configured as a cry out function. So if you say you set up your data to be sent back every 5 minutes with that cry out feature, if it detects a change in state on that digital, it'll wake up and send immediately. So if you have it connected in, say, to an alarm input or something like that, you'll be notified immediately. 2 RS-45 channels for bringing back Modbus data. So up to 20 Modbus registers can be sent back. And that long battery life we talked about before and the intrinsically safe design that can be put right there in the hazardous area are what make this product line a real advantage. You go to the next slide, please. And ultimately, what you care about is being able to monitor that data and get it back so you can make decisions and understand what's going on. And this is where you can deploy a gateway for your RNG facility, which is going to create that LoRaWAN coverage to receive all the data packets coming back from aircoms that could be scattered around that RNG facility, and then ultimately build a web-based dashboard to be able to monitor all those different parameters through your RNG process and bring those right back to where you can see it in a meaningful way and create a customized dashboard to kind of look at what's going on inside your process. And this is just showing a snapshot of a dashboard we built out for odorization monitoring. So we could take this and expand upon this concept for your RNG station as well. So in summary, you can leverage the Aircom products to be able to connect up to any sensors in your process, be able to bring that data from the hazardous area back, ultimately to a web-based dashboard so you can see it and make decisions to help improve and increase efficiency.
Hi, I'm Josh Denigi. I'll cover the low pressure pumps. So the pumping applications in RNG are vast throughout the entire process of production of the natural gas. We have a number of different pumping solutions from the Ingersoll Rand brands. This includes chemical metering pumps on the low and high pressure side. In terms of chemical metering pumps, on the low pressure side, we have a wide range of solenoid driven and motor driven diaphragm metering pumps, as well as peristaltic pumps, and then also hydraulically actuated diaphragm pumps as well for higher pressure applications throughout this process. On the low pressure side, the solenoid pumps and the motor driven diaphragm pumps, as well as controllers, work seamlessly together in order to balance chemistry and water, especially on the early stages of the process during the anaerobic biodigester side. Flow ranges of these pumps in a wide number of pump varieties range from 0.06 liters per hour as high as 200 liters per hour as optional flows, with significant turn down in each range. Pressures for the solenoid pumps include as low as just under 1 bar all the way up to 30.6 bars. This is really covering the full range of requirement for water treatment, as water is required for and then produced out of the process for RNG, and then must be treated in that process. In addition, in-process pumps for the digesters are required to balance chemistry in the anaerobic digesters and efficiently work through that process. So some of the available technologies that we have and applications that we can go into include solenoid and motor-driven pumps. These have special designed heads, which are fast prime and auto prime, as well as multifunction valves for maximizing the uptime of the pumps, minimizing the requirement for maintenance people to be working on the pumps. It makes setup and commissioning and running, as well as maintaining these pumps, quick and efficient, and they're also inherently safe. So a solenoid pump and also our motor-driven pumps, in any case of overpressure or chemistry issues, especially if linked to a controller or the SCADA system being used in process, are going to be able to be fully controlled and safe. There's multiple control options for these pumps as well, including simple on-off control to the pumps. There's pulse control and frequency, which can be brought from a controller or a SCADA system. And there's full SCADA integration with 4 to 20 milliamp signals and dry contact relays, as well as the available industrial protocols, including Modbus over RTU, TCP, Profibus, and Profinet in select models. The controllers of LMI pumps provide real-time feedback for control of conductivity, ORP or redox, as well as pH control. If we go to the next slide, some of the applications that you might see in RNG are primarily related to processed water and produced water, and treating that water out of that RNG applications from source to cleanup and in-process remediation. Applications primarily in terms of chemicals that are being pumped through these include disinfectant chemicals, coagulants and flocculants, such as different types of polymers, water and oil-based polymers, pH control, and H2S control, among many other applications where chemistry balancing is required in order to produce the RNG gas, and then also to be able to remediate water that's produced out of this process. One of the great advantages of a solenoid metering pump is it provides plus or minus 1% of steady state accuracy. As I said, there's fast prime and multifunction valves for inherent safety and easy commissioning of the pump, and full SCADA integration and industrial protocols as well. In addition to the diaphragm metering pumps, we also have peristaltic metering pumps as well. Peristaltic pumps are preferred in many applications, especially in the RNG market, again, because of the simplicity of setting up and operating these pumps, and also the low cost of maintenance associated to these pumps. Unlike many other pumps or pump technologies that are out there and available for chemical metering, there's only one wear part on a benchtop peristaltic pump, and that's the tube element. And also the tube element is the only element within the pump that's in contact with the process fluid. This makes selection of the pump and setup and commissioning simple, and then ongoing maintenance is not only predictable and can be scheduled in process to increase uptime, reduce the risk of downtime, but also to make the selection of the chemistry for the specific material in the tube simple and easy. There's 3 different sizes of our benchtop peristaltic pump. This ranges from a max flow rate of 17 gallons per hour all the way up to a max flow rate of 158.7 gallons per hour, 65 liters per hour up to 600 liters per hour, and comes standard with a 2500 to 1 turn down. So there's really a wide range of applications for these pumps to go into. Really any application that a diaphragm pump can be used, a peristaltic pump can be used in as well. It's a true positive displacement pump, meaning you're not going to have slip through the pump, and you're going to get accuracy and reliability throughout the entire lifespan of the pump in balancing water chemistry. All models of the peristaltic metering pumps come standard with SCADA connectivity options. That includes 4 to 20 milliamp inputs and outputs for integration into SCADA systems, 4 digital outputs, 3 contact relays, as well as frequency and 0 to 10 outputs. Some of the applications and advantages of the peristaltic pumps include water treatment across the RNG process. Again, especially advantageous in off-gassing disinfectant chemicals or dirty and abrasive chemicals where there's solids or abrasives involved in the chemistry, and high viscosity applications, especially flocculants and coagulants in the water treatment process. This is a true positive displacement pump, meaning you're going to get a significantly higher degree of accuracy and repeatability out of the pump, and be able to maximize the use of chemistry in process and ensure reliability throughout the entire system. It's also a sealless design. So this means that the use of the pump and the maintenance of the pump is minimized. In addition to what we call our low pressure chemical metering pumps, primarily in the water treatment sector, we also have higher pressure oil-filled or hydraulically actuated diaphragm pumps. So this is the MROY series of industrial diaphragm pumps. Flow range in the MROY series, and as you can see, these are typically AC motor-driven pumps. They go from as low as 1.45 liters per hour, as high and all the way up to 321 liters per hour, and pressures from 3 bar to 207 bar. So a significantly higher pressure pump, which is achieved through the hydraulically actuated diaphragm. The temperature ranges are very wide in these as well, and all MROY pumps include a hydraulically balanced PTFE diaphragm. This is designed for 96,000 hours of operating life. So these pumps are known in the RNG process for being reliable, being long-lasting, and being able to provide consistent results in balancing chemistry, both, again, on the water treatment side and in process of RNG production. You're going to be able to achieve a plus or minus 1% steady state accuracy over a 10 to 1 turn down range. So these are versatile pumps. While they're more industrial, higher flows, and also higher pressures, you're still getting the accuracy and repeatability that you would expect from a chemical metering pump. There's a single oil-filled gear in the hydraulic system, and this eliminates any crosshead seals or the requirement for repair of seals. So total cost of ownership is lower with these pumps as well, especially compared to other technologies used for chemistry balancing and in-process pumps for RNG. They're easy to prime, so you have bleeder valves for priming the pumps, and also, again, very low total cost of ownership and simple design.
Thank you, Josh. So my name is Benjamin Maréchal. I'm the Global Product Manager for peristaltic pumps. Next slide, please. So let's talk about Albin pump, our peristaltic technology. So the principle first, so we usually call this pump a hose pump. The fluid passes through a flexible hoses, which is the only part in contact with the fluid. And by means of shoes mounted on the rotor, you can see on the picture below, the hose is alternately compressed and relaxed. And that creates a continuous section at the inlet of the pump, moving the fluid through the hose and at the discharge. And this leads to benefits which are very useful for biogas and RNG applications. So first, there is no backflow with this technology. That means there is no wear due to abrasion. There is no slip, so 100% volumetrically efficient. This is a sealless design, so there is no dynamic seal to leak or wear out. This is a simple design, especially with this plug-in shaft design between the gearbox shaft and the rotor. Only one wearing part, the hose. We can make the maintenance in place. We can run dry this technology. We can move vapor. This is a reversible technology. Also, we can remove suction side blockage, and that's very useful for your application. It's a self-priming technology up to 9.5 meters, sorry. We can handle solids up to 65% by volume, very accurate, plus minus 1%. And that's also gentle to product being pumped. That means there is low shear. Next slide, please. So just to give you a snapshot of a very typical application for biogas. So here is a case study transferring digestate and glycerin with a big ALH pump. This is an ALH 125, which is a 5-inch pump in a single head configuration. For this application, we have a natural rubber hose, which is the best option for flexibility and mechanical strength. And that's a very heavy duty application, 55 cubic meters at 50 Hertz. The pump is running between 25 and 30 RPM with a 30 kilowatt motor. You can see on the right picture, a pulsation dampener to prevent the installation from hammer effect. So it will help reducing the total cost of ownership. And this application is typically 15 hours a day, with a back pressure of 5 bar. And we are handling 12% dry matter at 40-60 degrees temperature with some particles with size below 35 millimeters. So that's typical application transferring digestate with this ALH series pump.
Hello, everyone. I'm Antoine Marin. I'm working in the Milton Roy Mixing Expertise Center in Avon, France. So you can find industrial mixers in the biogas production part, and you can find it in two different items. The first one is the mixing pit, where all the agriculture waste, the wastewater, the sludge, the stocks waste will be mixed together and then put in the digester tanks, where the mixer will ensure heat transfer and avoid all the solid settlings. Next slide, please. So for the digester tanks, you can find two types of industrial mixers. The first type is the side entry mixer. So like the name says, it's installed on the shell of the tank. And compared to submersible mixers that you can also find in this type of application, the main interest of the advantage point of this mixer is that all the wearing parts are outside the tank, so you don't need to empty the tanks, you don't need to touch the waste to ensure the work and the maintenance. So for the side entry mixers, the wearing part, the main wearing part is the mechanical seal that you see on the bottom left. And this mechanical seal, like I said, it can be removed without touching the mixer, without emptying the tank, using the shut-off device. That's the green cone you see on the left. And also to ensure the best reliability of the system, we join the mechanical seal with the pressurized pot that will send the liquid to avoid solids to go in the mechanical seal and increase the reliability. These side entry mixers, they need to be with an angle generally 10 degrees on the left, because you see this is CFD simulation, but this is simulations we can do in our office to show and optimize the mixing effect generated by our mixers. And you see that if you don't have this angle on the left, you will have dead zones on some part of the tanks, that the green area you see on the left. While if you put this angle, you will have a proper homogenization. Yeah, next slide, please. The other type of digester mixer you will find are vertical ones. So for these ones, the motor will be installed on the top of the tank and not on the side. In this case, the sealing is ensured with the hydraulic seal system, which is zero maintenance and no wearing parts, so a very long lifetime of the mixer. And the mixing is ensured by actual propeller saber design, so really homemade design, which by this special shape avoid the accumulation of racks and solid on the blades and ensure high reliability. Please. And finally, for the pit tank, so we use vertical mixer. Generally, the tank are smaller, and so we use smaller vertical mixers, but with which are very robust because we have all these different waste coming from different origins. It can be, like I said, wastewater or agricultural waste. So we need this actual propeller with high robust mechanical design to ensure proper mixing and high lifetime. And for that also we can do CFD simulation to show and ensure.
Yes.
Yeah.
I think we'll have time to play one of them, Antoine,
yeah, okay.
but we are a bit behind, so we'll.
Yeah, I know. So you see the CFD simulation at the center now. So this is something we can do here in our office to show our design and also help you improve your process. So, and for the.
Thank you, Antoine. Hello, everybody. Thanks once again for joining. My name is Federico Carluccio. I'm the Business Development Manager for Biogas Compressors, covering EMEA territory based in Spain, Madrid. Today, I'm going to briefly give you an overview of our product, what are our capabilities, what we can do for you. I will start by telling you that the core of our business is delivering tailor-made solution according to the most demand requirements of our clients. Yes, we are a very flexible brand. We have the capability of delivering a full package, module, or just a gas end. We are very experienced. We have lots of years working on different kind of markets and applications, as you can see in this chart. Just for an example, in the oil and gas industry, for example, vehicle recovery units or biogas applications and carbon capture and storage in some of industrials and processes. In the next slide, this picture is just to give you an overview of how our product looks like. This here you will find the main components. Today, for lack of time, we'll just make focus on our block compressor that in the next slide, you can see that we have two different types of gas ends. Yes, we can deliver it in a single stage version or in a two-stage version. In the next slide, you can see some of the features of our block compressors. They can be gear drive or direct driven. There's no need for an external pump loop or preloop pump. There's one internal that we can deliver if the occasion demands. For the one-stage solution, the maximum discharge pressure is 24 bar Gs. The flow is 18 cubic meter hour. And for the two-stage solution, the maximum discharge pressure is 34 bar Gs with a maximum flow of 6 meters cubic hour. In the next chart, you would have a full view of the range of our equipment. Yes, single stage and double stage again here, starting from 15 kilowatts to 600 kilowatts. Our small unit delivers 235 cubic meters hour. The biggest one, as mentioned before, in one stage, 18,000 cubic meters hour. All our equipment comes with lots of features and optionals, such as instrumentation, scrubber, blowers, enclosures that we are not going to mention today. And these pictures is just to, as I was speaking before, you see that we have the capability of delivering tailor-made solution, full package, key in hand. We can deliver a module to finish mounting our site, or just the gas end, maybe for the profile of customers that are packagers, we can deliver this for you. Following the last slide is just a reminder for you if you want to get in contact with us, key technical information that we would need, basic, to address a solution for you. Yes, the basic things, discharge pressure and flow, inlet pressure also, and mainly gas application that many times people forget. This is key for us to analyze it and see if our compressor is suitable for that. Last but not least, just this is to measure our centrifugal gas compressor team, AGS, just for you to know that we have solutions in centrifugal gas compressors also. I will give Ravi again the voice. He will round up this and we will move to Q&A section.
Yeah, thank you for that. So on the closing section of the slide, so this is the last slide before we move on to Q&A. In essence, our customers face significant hurdles in their day-to-day operations, and they encounter the frustration of unreliable equipment, which directly impacts the productivity and effectiveness, and the complexity of integrating different systems, whether it's the biogas production or upgrading of biogas to biomethane, presents a formidable challenge for them, leading to disruptions and inefficiency. And with these difficulties, what we have noticed is there is a pressing need for single source solution provider, a partner who can address all their needs comprehensively. And as you've seen, our wide range of products, coupled with our reputation for reliability and quality and deep understanding of our customers' pain points and needs, we are well positioned to offer that tailored solution to enhance their operations. Moreover, our extensive and proven experience collaborating with key players in the biomethane sectors across North America and Europe cements our position and reputation as preferred choice for biomethane equipment needs. And with that, we come to the end of this presentation, and I'll pass it to Corinne for Q&A session. Thank you, everyone.
Fantastic. Thank you, everybody. It was quite a whistle-stop tour of a very detailed process, but thank you for all of our presenters for putting those slides together and explaining as best they could with a very short amount of time. Just wanted to draw your attention to the fact that if you wanted more information about how all of these brands fit together, if you go to ingersollrand.com/RNG, then you will be able to get a link to all the different brands that are mentioned here, along with contact forms, requests for quotes. So that's a really easy way for you to get in touch, ingersollrand.com/RNG. And I'm pleased to say that we've had a number of questions. We've had almost 20 questions. They've all been answered directly to the relevant people, but I think we might just take an opportunity just to run through a couple of those that might be relevant for other people as well. We had a question about what is the CapEx MMSCFD, which sounds amazing, of biomethane, general ballpark numbers and how it varies with regards to technology and feedstock. And Avinash commented that the CapEx depends on the size of the plant and the technology used. So generally, it's a range of USD 65 to 80 CapEx MMBTU. So there are, if anyone has any more questions, please pop them into the Q&A button now, and we'll just run through the final bits to make sure that we finish on time. We had some other questions about if you'll be able to get a recording of this presentation, which you will. We will send this out after the webinar, so you can pass it on to family and friends, perhaps. Also, questions about the measurement formula to use in gathering the ROI of biomethane product. And Avinash very kindly explained that the ROI of a biomethane project depends on the project size, manpower used, feedstock type, upgrading technology used, offtake agreements, tax credits, and feed-in tariffs of that particular country. So all of these factors, among others, should be considered for calculating the ROI. And we've had a number of different people from all over the world today joining us, from Uganda, Madagascar, Nigeria, quite the international feedback. I think we had some, are there any further questions? There's one more question here, and that is from Rukmini. We'll pass it to one of our presenters. Do you offer gas chromatographs? And Steve from YZ Systems is going to answer that. If you would like to get in touch with us, I just draw your attention again to the website ingersollrand.com/RNG, where you can get in touch with any of the brands that have presented today. If you're looking for compressors or mixers or pumps or odorizers or IoT solutions, then that would probably be the easiest way for you to find all that information. And Benjamin will be contacting Jeremy, saying that they're in Ghana and they are working to set up an industrial biogas plant in Benin, where they have 300,000 tons of organic waste to treat into methane for households. So fantastic. There are really some connections happening during the webinar today. Any final last questions before we finish? Otherwise, I think it just remains for me to say thank you very much to everybody for your time, for joining in, and to the presenters for putting the slides together and talking us through in a very short time all of the different elements involved in the RNG production and upgrading process. I think with that, thank you very much to everybody, and we will send you a copy of the presentation. Oh, here we go. Last question here, just in before the gap. Emmanuel, do you supply a full set of equipment? Depends who we want to go to for this, but I think each of the brands offers not just the products, but also the solutions to put that in. He's saying for landfill gas making. I think we'll be able to answer that question for you, Emmanuel. Here we go. Louis will be answering that and sending that over to you. So thank you to everybody for your time and for joining in. I think this was the start of our RNG webinars. We might be able to offer some more in the coming months. Thank you for your time and for attending. Have a great day.
Thank you. Have a good day.
Thank you.
Thank you all.
Thank you. Bye.